Students, today in this class we are going to learn about a hybridization topic in chemical bonding, an important one for higher studies also, that is 11th class chemistry also, 10th class physical science chemistry part, what is a hybridization, and most important topic for 8 marks in public examination in 10th class in both states, Telangana and AP, and also in central CBSE syllabus. So what is hybridization? Hybridization takes place in the valence shell, between s and p orbitals, in an atom. This is in the valence shell between s and p orbitals in an atom takes place, not between the atoms, only in one atom between s and p orbitals. So by redistributing electrons from s orbital into p orbital, So like that. So in an atom in the valence shell, when electrons are distributed from s orbital into p orbitals, so then hybridization takes place. In the hybridization, s orbital can intermix with p orbitals. So here s orbital intermixes with p orbitals. That may be 1 p orbital or 2 p orbitals or 3 p orbitals, that is px orbital or py orbital or pz orbital, or 2 orbitals or 3 p orbitals. So when an atom participates in the chemical reaction with other atoms, in an atom in the valence shell between s and p orbitals, hybridization takes place. So in this case, electrons will be redistributed from s orbital into p orbitals. Then s orbital intermixes with p orbitals. Now s orbital and p orbitals are changed into hybrid orbitals. So this is related to a basic concept in hybridization. Now we are taking an example. For example, carbon we are taking. Carbon, you know, atomic number is 6. Its electron configuration is 1s2, 2s2, 2p2. In terms of Hund's rule, we can write as 1s2, 2s2, 2px1, 2py1, 2pz0. When carbon atom participates in the chemical reaction, now if you take, this is a valence shell. In the valence shell between s and p orbitals in an atom, hybridization takes place. So second shell is the valence shell. When carbon atom participates in the chemical reaction with another atom, then the electron, one electron in the 2s orbital will get more energy and will be excited, and it is jumping into 2pz, jumping into 2pz. Then we want to understand this 2s is intermixing with px, py and pz. So now remaining electron, this one is 2s1, 2px1, 2py1 and 2pz1, because one electron goes into, but here we written by redistributing electrons from s orbital into p orbital. So one electron jumps into pz. Electron is jumping into pz means between pz and 2s there is a px orbital and py orbital. So sc is combining with px, py, pz by transferring its electron, one electron into 2pz. So then here it is written, students. So s orbital intermixes with px, py, pz. This is next. S orbital and p orbitals are changed into hybrid orbitals. So now this converts into sp3 hybrid orbital, sp3 hybrid orbital, sp3 hybrid orbital, sp3 hybrid orbital. How like this is? Now this 2s becomes sp3, this 2s px becomes sp3, it is sp3, it is sp3. So now this is its electron, it is its electron, it is its electron. But what is the shape of this one? So s orbital, students, s orbital. You know s orbital shape is spherical. Px, py, pz. It is px, it is py, it is pz. These two are intermixing. Now they are forming a new kind of hybrid orbital. This is. It is a hybrid orbital. So when s orbital intermixes with px, py, pz. It is a px, it is a py, it is a pz. It is a s orbital, that is 2s, 2py, 2pz, 2px. Then resultant s orbital and p orbital are changed into hybrid orbitals. So hybrid orbital name is here sp3. How many hybrid orbitals are formed? 4. 1, 2, 3, 4. Because 4 are intermixing. 2s, 2px, 2py, 2pz. So it is sp3, it is sp3, it is sp3, it is sp3. So this is its a nucleus. 3 are combined. So from this we can write what is hybridization. So we can write what is hybridization. So the phenomenon of intermixing orbitals in the valence shell having almost equal energy by redistributing electrons is called hybridization. Now we can write the definition clearly, students. So clearly we can write a definition. What is hybridization? What is hybridization? Now the definition of hybridization, students. The phenomenon of intermixing orbitals of a valence shell having almost equal energy by redistributing electrons is called hybridization. Students, one thing everyone has to remember, that is hybridization is not taken between the atoms, only in one atom in its valence shell among the orbitals having equal energy. So when they combine, when they intermix by redistributing electrons, it happens. So in the hybridization, number of hybrid orbitals formed, number of orbitals intermixing equal to number of orbitals intermixing equal to number of hybrid orbitals formed, number of hybrid orbitals formed. So intermixing orbitals example, students, s orbital, px orbital, s plus px, s plus px plus py, s plus px plus py plus pz. So like that. So these are pure atomic orbital. Valence shell s orbital may intermix with one px, s may combine with px and py, s may combine with px, py, pz. So then how many hybrid orbitals are formed? Number of orbitals intermixing equal to number of hybrid orbitals formed. So 2 here, 3 here, 4. So number of intermixing 2, so number of hybrid orbitals formed 2. Number of orbitals intermixing 3, number of hybrid orbitals formed 3. So number of orbitals intermixing 3, so 3 plus 1 4. So number of hybrid orbitals are formed equal to 4. Now in the next class, how many types of hybridization between s and p orbitals we can discuss, students. So in the next video, this is hybridization, what is, and basic concept of hybridization. So important topic. For many important topics, so you can follow Physics Krishna Reddy YouTube channel. That's all today's class.